Hello, you are now entering the infinite void. Hang on tight. We cannot save you now.
Hello and welcome to this week's episode. I'm your co-host Jacob.
And I'm your co-host Matty, and this week's episode is on interplanetary contamination. So it's going to be a fun one, I think. I guess this sort of started with last week's episode at the end. I said about the film Life, which I'm sure we'll come on to, and it's sort of spawned this idea of contamination between planets and between sort of moons and celestial bodies.
Yes. I think
this is something I've really, really been interested in for a long time. Even way back at like high school, I love this sort of stuff. So
it's interesting because I'd never really thought about it, if I'm honest with you, but it makes sense because in history and stuff, you learn about how say the Spanish and stuff traveled to South America, and you have like these tribes and stuff that don't have the same immune system, for instance. I know this is a little bit more out there because we're talking about proper life now, but you have these tribes and stuff in the Amazon that have been wiped out because they weren't immune to just certain flus and stuff. And I guess it makes total sense because things are going to grow up on different planets and different moons. And yeah, I just think it's actually it's actually a really good point. Until you'd mentioned it last week and until I'd seen the film Life, I hadn't really put much thought into it. And I guess when we were sending probes and robotics into space, it wasn't too much of an issue. But certainly as the future becomes more crude, it's definitely going to become more of a problem for sure.
Yeah, I mean, I can definitely see myself, if A-level biology hadn't completely turned me against biological sciences, I could definitely see myself being an astrobiologist. It's such a amazing amalgamation of things, and such an interesting area to work in. But I guess we'll just sort of start with some basic definitions now, for people, as you said, probably aren't familiar with it. I think the main sort of words that you'll come across is this idea of forward and back contamination, which we were discussing about before we recorded. So just so people have an idea of sort of this contamination, in the film Life, that's talking about something coming from Mars, was it?
Yes, Mars, I think.
This Martian life form coming to Earth and sort of killing us all was the idea of it. But that would be the idea of back contamination. So that's stuff coming from other planets or other bodies to Earth. But then the flip side of that is forward contamination, where you have Earth-like sort of organisms being transported to other bodies, and potentially, I guess at a basic level, it sort of alters the science and stuff. If you send a probe to Mars and you're looking for life, but your probe is contaminated with life, then you can't really do any meaningful science with that. That's one problem with it. And the other thing is, if we're sending it to these sort of these areas where we think there might be life, and like you said, with sort of the Europeans going over to the Americas, sort of contaminating it and potentially killing things there through contamination. So that's the idea of forward contamination. Just so people understand, we're probably going to be talking about both of those.
No, I think that's a good point. Something that's just randomly popped into my head. Do you think, just out of curiosity, that this happens naturally across the universe with asteroids?
But there is this. This is one of the theories for how life on Earth started. It was sort of transported here by asteroids. I think it's definitely possible. Organisms, they call tardigrades, I think. They've sort of survived crash landings on the moon and stuff.
Is it India that spilt them on the moon?
Yeah, they sort of spilt them on the moon, and they think they survived. And we know that tardigrades can survive hundreds of degrees Celsius and no oxygen environments and all these sorts of things. So there are life forms that could potentially get past the physical limitations of burning up in the atmosphere and surviving deep space transport and stuff. That's definitely possible. Space is very big, and if you have an asteroid with stuff on it, there's a very, very small chance it will land on any meaningful planet. And
Yeah, especially one that could even like support it going forward,
Yeah.
kind of thing.
Yeah. But I think, well, it's very. We're sort of going off topic already here, aren't we? But it's definitely a possibility, and it's quite, in a simple way, it's a very easy possibility. Rather than trying to imagine like life evolving from basic like atomic molecules into something that's conscious, is very, very difficult. If it arrived here already as a living thing, that makes sense. But then obviously you got the question of where did that thing come from? So
it had to start somewhere. Yeah, I guess.
Yeah,
That's a good point. Yeah, I'd never actually thought about it until you literally were just going through both of those examples. I was like, obviously I'd heard of the idea that humans didn't like originate from here, and maybe some of our like microbes and stuff had come in on an asteroid. But I was just thinking, like, I wonder like what the percentage is or what the probability is, like how often this happens, because I'd imagine that, because we like, even when we look at exoplanets and stuff, we found quite a lot of planets that could support life. And obviously if there's a catastrophe on that planet, if like two collide or something, and it sends all this debris up into the air and all these asteroids out in every direction, it would be interesting to see like if life just still finds a way. Do you know what I mean? But I guess one thing that would come from this actually is when we do a little bit more research with like the Oort cloud and stuff, when we start sending more probes there, because I can imagine if we like find microbes and stuff on all these asteroids that we're currently checking, it could definitely open up some doors for sure.
But potentially not even things from out of our solar system. If we found life on the moon or Mars, you know, they're regularly meteorites from the moon and Mars, you know, bits that have been blown off by other asteroids or have just naturally drifted off in the early solar system. Meteorites from those objects do come to Earth. You know, you can find moon rocks on Earth and things. So there's potential that life could come from, you know, another object within our own solar system. You know, perhaps, you know, we say Mars, we think that Mars sort of millions and billions of years ago had water on it and could potentially sustain life. Perhaps all life on Earth sort of began on Mars. Mars was sort of like the very, very first breeding grounds, whether, you know, it evolved there or came from somewhere out the solar system. But perhaps Mars was the sort of seed for life in our solar system, and then just through one way or another, Mars sort of fell off the wayside sort of thing, and life just sort of came to Earth instead, sort of thing. So.
Can you imagine, just going quickly back to the idea of like the Great Filter making everything even more improbable? Can you imagine like the idea that like, say that life started on Mars, but for it to become like intelligent life, it had to like have a planet like Earth or something. So life starts on a planet that's further away from the sun, but then it has to, whilst it's in its early evolutional stages, it needs to be transported to another planet that has a better host for it, kind of thing.
Yeah, definitely. Like, as I said, I'm not massively up on my planetary science. I don't know what. I know certainly Earth billions of years ago was pretty hostile.
Yeah.
You know, very sort of volcanic and things. You know, it was potentially Mars back then, which was better for like life to start. It happened to come to Earth, and at some point there was life on Earth and on Mars, and then the life on Mars just sort of died, and Earth became the more preferable planet to sort of advanced life to evolve on. You know, that's one option.
Because have you watched the program? I don't know the title of this program now, so I'm sorry if I butcher this. But there's a program on Netflix about humans going to Mars. Have you watched this?
I've not. No.
It's pretty good. I can't remember what it's called, but it's all about like the Mars missions and when they go there, and it's the first like little settlement, and it's quite good because America basically gets there and they're building like the first little bit, kind of like The Martian in a way. And then China get there the year after, and they've both got two settlements, but they're not working together.
Yeah.
And I think it's the Chinese, they're digging into like a mine, or they're like mining something, but they like burst into like this pocket cave, and somebody gets infected, but it's not like the, oh, it's so scary kind of like everyone's going to die kind of thing. It's more so the idea that when it happens, they realize that this like bacteria on Mars, it hasn't had like it hasn't been built up to like have the immunity like the bacteria here on Earth, and they literally solve it by giving it basic penicillin, because they have this like this new piece of bacteria just hasn't experienced anything, and they solve it like that. But it's really smart how they do it, because they're worried and they like quarantine a little bit off this thing, and everybody's coughing. They don't know what to do, but they literally solve it straight away by something so simple. And I was like, that's a good point. Not that it would be like that, but it was an interesting way that they like approached it.
Yeah, it's interesting you say that, actually, that potentially sort of a disease from another planet will be quite easy to cure because it's not resistant to our medicines yet.
Yeah.
One thing I saw, I'm sure I saw it on Twitter this week. It was I think someone that writes about space and things. I honestly can't remember who it was though. They were talking about this satellite in Earth orbit. I think the Russians launched it back in like the 70s or 80s or something, with some like bacteria or microscopic life on it. And they sort of lost control of it and just sort of abandoned it in space. So this like bacteria has been up in space for like 40 years, and there's potential that it's going to be deorbited. It's going to sort of land back on Earth. And they were saying like this bacteria has been like in one of the harshest environments for like 40 years, has been like dealing with like really, really strong radiation and stuff, and now it's potentially coming back to Earth. And like that's sort of the flip side of it. Yeah, it's not being subjected to our medicines and things, but any life that's living on, you know, even natural satellites that has just managed to go up there and survive for a while, or asteroids and things, has been having to deal with the physical sort of
Yeah, that's quite scary.
yeah, you know, like we treat a lot of things with sort of radiation and sort of proton therapy and x-rays and things, obviously. So to think that there's something that's sort of been living in those conditions for years,
and it's like survive, yeah, like built, like you're saying, it like could have built immunity to it, could come back down to Earth and be like, oh, this is easy.
yeah,
Yeah, totally. That's quite a scary idea.
yeah, that's the flip side of it. But yeah, I guess so. When you were sort of looking into this stuff, because I know you said you were not that familiar with it, what sort of things did you sort of come across? I guess that would be a good place to start.
So what I basically found first was the idea, as you were saying, with like forward contamination and backwards contamination. And then they were basically talking about like the main focuses of those things. So like, as you were saying, with satellites, they obviously blast them with loads of stuff, and it's very easy to sterilize like robotics or metals, as you were saying, to put them up in space. But where I found it interesting was the idea of how we're going to like sterilize spacecraft and stuff for crew missions, and the idea of back contamination from certain planets in our solar system, because it's obviously not all of them. There's only a few so far anyway that we've been looking at that could potentially have any back contamination when we send things there. No, I think it's weird. It's so weird because I just never thought about it when, like, I was reading here about how they were talking about what they do with the robotics and the spacecraft. Because isn't that what's happened with, what's it called? What's the one that they delayed from something? There was one that they delayed a couple of weeks ago in China because there was an outbreak in the lab or something.
I honestly don't know.
Okay, forget that. I don't know where that one is, but I saw something that basically they'd been pushed back by like 2 weeks because something had happened.
Mm-hmm.
But yeah, I was just reading about the idea of like contamination basically and how they were doing it with robots. But it sounds like it's more of a problem when it comes to sending humans up.
Yeah, I think that's my understanding of it. I guess we'll come on to it later because I've got a bit to sort of discuss about the different levels of quarantining that people do, depending on the planets that we're going to. But I need to refer to notes for that because there's quite a lot of numbers and acronyms and stuff. But yeah, there's these sort of different levels and stuff. So, you know, obviously there's no quarantining and you can build stuff in clean environments. And then at the sort of far end of it, you know, these satellites and robotics are in some cases autoclaved, so like heated to kill anything, and they often sterilize it with radiation and things, and obviously sort of antibacterial stuff as well. So there's lots of sort of different levels to it, but yeah, the human one is quite interesting. It's quite a problem because you can radiate an autoclave a machine. You can't radiate an autoclave people. So,
Yeah.
but yeah, the reason why I found this interesting, I'm thinking back to like when I was a kid. It sort of shocked me that it was the Apollo missions. Like in my head, like when the Apollo missions finished, like the people land on the Earth, they're plucked out the sea, they're taken back to America, and then they just be in my head, they'd just be put in like fancy cars and like traveled across America as like great American heroes. Like pretty much immediately just doing press conferences and stuff.
Yeah.
But actually they spent like I think a week or 2 weeks in quarantine immediately after sort of landing on Earth. Like the door was open to their the landing module, the re-entry capsule. The door was opened, and then they were like put in a bubble, transported in like a quarantine van, and then like kept in a building for like 2 weeks to avoid like contamination back from the moon. And I guess since those Apollo missions, we haven't done that because we haven't sent anyone anywhere. So,
yeah, that's a very good point actually, because they were very worried about it, weren't they?
They were. If you like read into like what they did for the Apollo mission stuff, they were genuinely quite fearful that they could bring back some space disease.
Yeah.
Like they built. We're not talking about they sort of like stayed in their room for a week or two and like people wore masks or wore gloves and stuff around them. Like they built like specialist lorries to transport people between buildings. There was a lot of thinking and a lot of technology that went into it to create stuff that was like completely isolated from Earth.
Yeah.
And yeah, it's quite interesting. That's sort of what piqued my imagination into it, because I just thought they'd just be put into a Cadillac and like American heroes.
Yeah, like chauffeured down the parade kind of thing.
Yeah. Sort of, yeah.
Yeah, it's interesting because you see, my mind this year with the whole like pandemic and everything that's going on, I think that's actually the first time we've made a nod to living in a pandemic on this podcast. So future historians, if you're ever any AI or any future humans watching this, if you're like going through all of our content, yep, we're in a pandemic. But it made me think now, even with like when we're getting rock samples and stuff from asteroids and stuff, because especially after watching that film Life, I know it sounds silly, but just the idea of like just bringing back rocks, because it doesn't have to be like a living, breathing like life form. It can be on like the microbe level too. Do you know what I mean?
Yeah, like definitely. Like this isn't something that keeps me up at night, but there is a potential massive risk here, and I think we do seem to have been getting a bit more lax with it and stuff. Like from what I understand, in the early days of space travel, basically everything was treated as if it could potentially kill us.
Yeah.
And now, part of that is the science. We know we've been to the moon a lot. We know a lot about the moon. It's incredibly unlikely there is meaningful life there. So, we take our chances, sort of thing. But yeah, it is interesting. And I think, yeah, because you were the one that actually like told me to watch Life. That was the reason I watched it, because you brought it up on a podcast, I think about a month ago now. And like, I was watching it, I was like, just all these flashbacks, like things I'd be thinking about. I was like, oh no.
Yeah. Yeah. Because it starts off exactly how it would start off here if we found life on another planet.
I think they do it a lot better than what we would do it. Like,
yeah, well, yeah. To be fair, even that, because like even then, it's on the space station, isn't it? Or is it? Yeah. Is it on a space station orbiting Earth, or is it orbiting Mars?
I think it's on the International Space Station.
Okay, yeah. So like even then, like we're not doing that. Like we've just been and got samples from the moon and brought them back to Earth, like here on the planet. Do you know what I mean? Yeah. So like even in that case, they're doing a more safer job than we are, because they brought it to the space station and they were keeping it up there with the whole idea that if anything went wrong, we'll push the International Space Station out into deep space, and it'll all be okay. And like, I know it's a film and it drastically goes from 1 to 11, but just the idea of it is terrifying. And when you're playing with stuff that you don't know, and like because like we really have no idea when it comes to life, because we've only really got one area of looking at it. Do you know what I mean? We don't have another example from another planet so much yet. So like, we don't know how quick anything could be, because we've only really got ourselves to go off.
Yeah, well, I guess I'll just say, like, spoilers for the film Life. If you've not seen it, you might want to turn away for a minute. But like, in this film, they sort of bring it back to the International Space Station and this like quarantine set up. And they have like these different levels of quarantine, but they say this is like a life form that functions differently. You know, unlike us where we have like specialized cells to do different things, they say it's like all of it is a muscle and all of it is a brain, and all of it is a sensing organism sort of thing. And then like in the film, this sort of thing goes from this dormant single cellular thing, and it grows into this thing that's basically just kills all the crew, and then it just becomes like almost like super intelligent, or at least, you know, really, really clever.
Yeah, it's like it's aware of its own like being, isn't it? And it doesn't want to die, so it's just trying to survive.
Yeah,
I think. But yeah, and just another thing as well, it doesn't just randomly evolve into this thing. Like, it doesn't just keep growing. Like, they are playing with it, and they are feeding it like glucose, and they are like turning the temperature up and giving it a little shake and stuff. And they basically kind of like get it on its way, don't they? And then as soon as it gets to a point where it can do the slightest bit of damage, it does. And then it uses that first human's energy and stuff to get a little bit stronger and a little bit more intelligent. And before you know it, this thing is probably, like, I would say, on par with them, and is wrecking everything pretty quickly. But seems to be better, because it's in space without a spacesuit at one point. So
and then like the end of the film is, I think it's a bit predictable, but like there's this clever twist of like these two capsules go off, and one of them's meant to be taking this alien like out into deep space as like a sacrifice, and then the other one's like coming back to Earth, and like the capsules get sort of mixed up in this like turn of events of stuff, and like the alien like eventually lands back on Earth, and it sort of ends with like the capsule being opened just as like.
But that bit is even scary, because it all goes wrong, they don't know where the capsule's going to land, do they? And it like lands off like this native island. And is it Jake Gyllenhaal's character when he's in there, and like these poor like native fishermen are like coming up to it on the boat, and he's like shouting, "Don't open it!" and they're trying to pry it open, and you're like, "Oh my god!" Because the minute that thing gets in the sea, we're done.
Yeah, it's pretty terrifying. But and like obviously this is like fiction. It's like the worst case scenario, but there is, you know, a risk with all of this stuff. You know, we find life, we bring it back. We don't know how it's going to react to a different environment. You know, like we said right at the beginning, you know, Mars is pretty inhospitable, and you know, maybe this thing is a really, really complex organism, and because it's been on Mars, it's just sort of dormant and it's not doing anything. And the moment it gets to the Earth with lots of water and lots of oxygen and lots of sunlight and energy and stuff, it just goes, sort of wakes up and does its thing, sort of thing. Kind of thing. So,
yeah, it's an interesting one. It definitely kept me up at night for sure.
But yeah, that's like the worst case scenario of bat contamination. Like that is as bad as it gets, kind of thing. But I think personally for me, the more interesting thing is this idea of forward contamination.
Yeah.
Of us accidentally contaminating things. And I know you had a list of sort of places that they're most concerned about, aren't they?
So here it says you've got Mars, obviously. You've got Europa, and you've got Enceladus. Is that right? I can never say that one. Enceladus. There you go.
Yeah.
And Enceladus and Europa are both moons of Jupiter. And then obviously Mars is the next planet that we're going to. But the reason why these ones they're most worried about is obviously because there's potential evidence for water on these planets. So we think that there could either be single cell or multi-cell life, depending on how far along it is. But yeah, I know I'd agree with you. I think forward contamination could be much more of a problem, especially with the way that everything's going, because we're only ever going to venture further out.
Yeah. I do think that there's this more sort of moral argument to this. It's like it would be absolutely terrible if we find life on sort of Enceladus or something, and then just immediately accidentally kill it.
Yeah.
that would be truly devastating. It just...
Yeah, because we already have made so many. I know it's not the same kind of thing, but there are so many animals on Earth that have gone extinct because of humans.
Yeah.
It would be such a horrible human thing to do, to find, as you're saying, life somewhere else, and then we just kill it.
I can just imagine us. We are this sort of petri dish experiment for a super intelligence outside of the solar system, and they're watching us, and they see us set foot on Enceladus and just put a big red cross next to.
Yeah, totally. Hey, that could be the Fermi paradox right there. Interplanetary contamination. Anything intelligent knows not to go in and contaminate another planet, because life forms should just be left to do their own thing.
Mm-hmm. Yeah, but I said earlier about these sort of categories and stuff and where these planets fit in. So I guess I'll just sort of go through those now. It makes sense.
Yeah, let's do it.
They're set by COSPAR, which is the Committee on Space Research, and they've basically it's sort of within the Outer Space Treaty. So the sort of Earth's sort of treaty on what we should be doing in space. It's the one that deals with no setting off nukes and no owning the moon sort of thing.
Yeah, these are guidelines for planetary protection, isn't it?
Yeah. Yeah, it's just sort of how we should conduct ourselves in space, I guess. There's similar things for how we use Antarctica and things. So
yeah.
But yeah, there's this one article of it is about contamination and how we deal with it, and they basically define 5 categories of missions that are dependent on the risk of contamination. So they say category 1 is a mission to a location not of direct interest, where they think there's no chance of biological or chemical activity. So this is the sun, Mercury sort of areas. So,
yeah.
Basically, they think there's no chance. Category 2 is things where there's interest in this sort of evolution, but is only remote. So they put in here Moon, Venus, most comets. That's sort of what they put in category 2. Category 3 is flybys of planets of significant interest where they think there's a good chance of life. So this is sort of flyby probes that are not actually going into the atmosphere at all. They're just sort of at a distance of Mars, Enceladus, Europa. Then 4 is landings and sort of probes landing on these objects, and there's a few sort of special ones, category 4A and B for Mars in particular, because they seem to think that's a special interest. And then category 5 is sort of returning samples from these sort of objects and planets. And I think looking at those categories, they're probably a good thing to have. I think in recent years they've probably become a bit outdated. Like Venus is in category 2 when only a few months ago there was the announcement of is it phosphine? Phosphine gas on Venus, so potentially life, and they seem to put Mars in this special category of category 4. When is Mars actually the most likely to have life, or is it going to be what the water worlds like Enceladus and things?
Yeah.
In the last sort of few years, there seems to have been a bit of a shift, and these sort of recommendations don't really seem to have caught up with it. But
no, yeah, I'd agree with you, especially with you're saying with Enceladus and Europa, because haven't we found pretty good evidence for oceans and stuff?
Yeah. I know. I always get these moons mixed up, but there's one which is basically an ice planet, and they think underneath the sort of ice crust is an entire planet's worth of ocean just there. Yeah,
I've got it here. So is it Enceladus? I can always get it wrong. Enceladus is an ocean-like composition. It's got liquid salt water, and it has an icy surface with a liquid saltwater ocean underneath. And it has a temperature ranging from minus 93 all the way up to 115 degrees Celsius. So it can have similar temperatures to Earth, depending on what its fluctuation is, and then Europa is a subsurface ocean, and it also has a magnetic field and another magnetic field supported by Jupiter. So they think that its atmosphere could hold in quite a lot of liquids. So they both seem more likely than Mars, because hasn't Mars lost like most of its atmosphere and stuff? I feel like with Mars, if we find anything, it will be proof that life might have existed in the past. But I'm not sure we'll find maybe living things, or if we do, it will be very basic. I don't think.
Yeah.
We'll find like skeletons or anything.
There's always things coming on about Mars. Like recently, they think there's a lot more water at the poles, and they think there's water trapped in the subsurface and stuff. But it's basically, I think, all ice.
Yeah, don't they think there's going to be lichens or something in like the permafrost?
Yeah, I think the feeling of Mars is it's going to be very basic stuff, and it's probably dead, or at least very, very frozen. So,
Yeah.
But yeah, Enceladus and Europa are ones that are really sort of big interest. And in particular, recently, there's a lot of sort of discussion about sending sort of really cool probes there. So, like sending submarines and flying. I think it's Enceladus has these like big plumes of like water. Like the water gets heated, I think, through tectonics or through some process, and then like spurts out of the ice.
Yeah, you can see it, can't you, in certain photos with it like going up out into the atmosphere.
Yeah, these massive plumes. I think they're tens, if not hundreds, of kilometers high.
Yeah.
They want to like fly a probe through them.
I think I've actually seen something online of like a robot or something somebody was building for one of these, that it was going to be able to like drill through the ice and then act as like a drone, but that works underwater.
Mm-hmm. Yeah. There's definitely sort of things they want to get under the ice, and I've seen sort of plans of submarines and things. So yeah,
awesome. It's very cool, isn't it?
Yeah, it's very cool, but it's obviously a lot of risk, and particularly if we start bringing stuff back.
Yeah.
But yeah, they basically, I've just seen at the end of this sort of list I've got on the restrictions, they say, sort of quoting here, the Category 4 missions, so this is like, in particular, the Mars ones, they sort of talk of this biological burden, and they sort of express it in chances of probability, chances of contamination being, they aim to have less than 1 in 10,000 chance of contamination, which seems like reasonable odds. So
yeah.
I guess as we sort of spread out more, we're already launching thousands of satellites around Earth every year. It won't be long until we sort of hit 10,000 things going out into the solar system, and that 1 in 10,000, although it's very small, it's not zero, is it?
Yeah. No, that's a very interesting point, and I think it's weird, isn't it? Because like when you think about it, like what is the solution? You almost want like robots building the robots.
Yeah.
And you almost want them building them like in orbit, not on planet Earth as well. You want like you almost want them to be built off Earth, and then the research to be done off Earth.
Yeah.
And then it to kind of like be returned, but that sounds like so much money. Can you imagine if we had to like build an ISS for every planet we just wanted to investigate that there was life for?
Yeah.
And then get it there, and then have like the robots doing that research on those things around those planets, kind of thing. It becomes almost impossible.
Mm-hmm.
So it almost feels like we either kind of like have to take a chance, or I don't know, like what other way do you go? Could you go more so the other way with like biology and say like CRISPR, for instance, and we really have to like hone in our own kind of like contamination and get ourselves to a point where we've completely like eradicated absolutely everything.
Mm-hmm. Yeah,
and we're not a threat anymore, kind of thing. I don't know.
Yeah, like obviously I love seeing space launches and stuff, and I love sort of us exploring the solar system, and that's not going to stop. Like, we're not going to stop doing that, but I think there's a very real question of whether we should be visiting these places just yet. Well, our technology is quite primitive. To me, it's sort of like back in the old days when we wanted to find out more about trees, and we just used to chop down the trees.
Yeah.
And then, oh no, we've chopped down this 1,500-year-old tree that could potentially be the oldest one in the world. And
Yeah.
I think they did that not recently. It was a few years ago now. It was with an oyster. Some researchers accidentally killed an oyster that was like 250 years old or something. Like they sort of plucked up and it was like, oh wow, that looks old. And to age them, I think it's like trees. You have to open them up and sort of count their growth.
Yeah.
I think rings or some sort of growth inside of them. And they opened it up, counted it, and were like, oh no, we've really messed up here.
That right there, I just feel like it's just humanity as a
Yeah.
whole sometimes, is that's just like what we do. We don't think sometimes, and we just like do it. But at the same time, you wouldn't get some of the progress and some of the leaps and innovation without it. But it's such a double-edged sword.
Yeah. Well, I genuinely think that sort of thing could happen when we're exploring places like. I really hope it doesn't happen, but I can perfectly imagine us going to Europa, sending our first like submarine. It gets there, and like something goes wrong. Like let's just say like a battery leaks in it or something.
Yeah.
And suddenly all of Europa is contaminated with traces of lead or something.
Yeah.
And we're like, oh no! If only we'd have waited like 10 more years, and we could have like just sort of understood it a bit more and made it a bit better. And like the oyster, we hadn't.
Yeah.
Or we hadn't chopped down the tree, we could come up with a better technology, a better solution. We just waited, and now we've sterilized this planet.
Yeah. No, totally. That's a very, very good point. And I think like who makes that decision too? That's the other problem.
Yeah.
Like, because I agree with you, because I feel like we shouldn't do things until we've got like either a better understanding or a better technology. But at the same time, like, how do you get that technology? We don't know when that technology is coming, and unfortunately, there are people on this planet that are curious and have really deep pockets. And the sad thing about certain humans is egos, and they want to know before they die too. So there's this big push sometimes to like get things done because somebody might want to see it in their lifetime if they're, say, funding this project.
Yeah.
And
well, a lot of biological science is learning from mistakes and things. We try things and they don't go quite as well as we want them to, and we sort of perfect them.
yeah,
So there is a bit of like, at some point we have to send the first thing. It's just whether that's now or in 5 years' time or in 50 years' time. But I genuinely think we should be maybe a bit more careful than we are being, especially as space becomes commercial, like you said, with like the egos. And with new countries, I'm not saying that like China's space program is any sort of worse or any less valid than America's or whatever. But
yeah,
as new countries with not as much experience doing this stuff, only America has put people on the moon.
yeah,
As they sort of develop, it won't be long until these sort of new technologies and new companies are sort of being propagated around the place. And someone says, oh yeah, let's go explore Mars, let's put someone on Mars, let's go dig up the Martian poles or something, and we find something that we weren't expecting, or things don't go as we planned, and it all goes a bit wrong.
yeah, totally. Because it's actually, even though it's like nothing to do with it, because space debris isn't like a living thing, it's very similar. Because as you're saying, like, you have nations that want to flex, they want to show now that they've got this capability, and that right now you're seeing it with space debris, and it's kind of like a little red flag for the next thing, which is what you're saying, which is like forward contamination, because that's the next big thing. You're already seeing countries right now that are like flexing with what they can put in space, and then like we saw not that long ago when that one got blown up and all that stuff that we spoke about. And this is the next step, isn't it? You're going to have countries flexing by sending things to other planets, either stick a flag in the ground, but even that in itself, if it's not done correctly, can go wrong. Do you know what I mean?
Yeah, definitely.
And I think, yeah, it's getting to a point where like that technology that gets you off planet, I don't know what you'd call that, but whatever that technology is, it's becoming more like open source. And it's going to be a lot harder to control, like we're seeing with space debris. It's becoming such a problem now because instead of like one nation, which I also don't agree with, I don't think that there should just be one nation doing it unless it's like a world nation, but that's a whole nother topic. But like the idea of like either we should all be doing it together and there is like a set rules, like you were saying with the idea of, what was it called? COSPA and the Outer Space Treaty and stuff like that. But there will come a time, even say like in 100 years, if a civilian has like a technology to be able to put something in space, because like what's stopping somebody in say like 200 years time having the technology like we do? Like, you know, when as a kid you might go in the garden and pick up some ants, put them in a test tube and play with them. Like, what's stopping a kid in 200 years time building something and sending it to Mars to get a sample? Because that might be a thing with technology. You never know. It could get way out of hand and you could have people dipping their toes in all sorts of stuff. And like, if it's not monitored, it's a really scary idea, because when you look at how we've treated this planet, we've contaminated the hell out of it. And
I agree.
And as a benchmark going forward, that's just not good. We can't even like do it here. So it's quite a scary idea, I think.
Yeah, but humans always try and just push the boundaries a little bit more, don't we? And
yeah, and I can't decide if that is our best trait or our worst trait.
I think it's a bit of both, you know. And I think, like you said, with like the Outer Space Treaty, this is going to have to be an area where there's some sort of, you know, international understanding on it. You know, there's no real way that you can stop countries doing this. You know, you can't stop China's space program. You can't stop China, or any other country, sort of going to the moon or whatever. But then there needs to be some international collaboration on things. I think.
Yeah. I don't know. I don't know. It's a very good point, and I hadn't really thought about it, if I'm honest with you. But you're totally right. Yeah. You're totally right, because the groundwork needs to be put in now as well. There needs to be like a said way of doing things, and I think there is. I don't think we're sitting here saying that, oh my God, it's free reign and everybody can do what they want, because they're obviously, like you are saying, there's the COSPA and there's the Outer Space Treaty and stuff. But there's gonna come a point when we are going to go to these places. And like you're saying, we just need to be careful, like we were at the beginning of the space race.
Yeah, I think you just dropped out for me then. But yeah, but I heard what you're saying.
Cool. But yeah, I think it's interesting. It's scary.
Yeah. No. That for me is why I personally think it's more important to focus on this forward contamination idea, because, you know, it's not the same, but if history tells us anything, is that usually the people colonizing are the ones that are spreading the diseases.
Yeah. Well, it's like we said earlier, isn't it? That might be the Fermi paradox. Forward contamination might be a real big issue in the universe, and if there is any intelligent life out there, they know better than to do that until that life on that planet is of a technology standard that they can look after themselves when said things arrive or whatever. I don't know.
Yeah, I agree. I think it's a really interesting sort of topic, and I'm glad you recommended me watching Life, because that sort of like tied everything together for me. That's like
yeah, it's like the nail in the coffin for the worst case scenario.
Yeah, like it doesn't get much worse than that. But I'd be interested to see if someone like did a film on this forward contamination idea, because I think that would have great legs. Like, I'd definitely watch that.
Yeah, I'm surprised that there's not like a book or anything about it. But no, I agree. I think that would be really cool.
Yeah.
But I've got this little bit here that I just wanted to read about crewed spacecraft, because I thought it was interesting. And they're basically saying here that like crewed spacecraft are particularly concerned for interplanetary contamination because of the impossibility to sterilize a human, as we were saying. This makes things really hard going forward for probabilities. Humans obviously have hundreds of trillions of microbes on them, so we can't just dip them in bleach. But they were saying here that the idea of like even water supply and stuff, it's not just the human, it's what the human needs to bring with them. And that in itself is a whole nother thing, because like obviously the water and stuff that we drink, we can't like fully sterilize it, but you obviously need to too. So it's just interesting. That was something that I hadn't really thought about, because you've obviously got like the food that the humans are going to eat, then you've got like the stools from the humans after they've eaten, you've got like the skin, you've got the breath. And even as we've seen like with this pandemic, it's quite hard to do this. Do you know what I mean? It's quite hard to like kind of like quarantine a place. So it's interesting, like going forward, how we would do that with like forward contamination, because we'll have to bring all this stuff with us. It's not just as easy as like sterilizing everybody before they go in, and then that's that. We've got to sterilize everything we're taking with us, and some of the stuff we can't. And then where do we get that? Like when we do go to these planets, are we going to like launch all of this stuff up into orbit, or are we going to bury it on the planet? And if we're going to bury it on the planet, are we putting it inside something? And then if we're putting it inside something, it then falls back to that idea of like, what symbols are we going to use to make sure that people don't go and dig this stuff up? And then are those symbols going to be lost over time, or do we need something that kind of transcends time? Because I read something, right, and this blew my mind, because this is a cool idea. So they were talking about like radiation, and you know how like some radiation, like when we're like burying isotopes now and stuff that have like insane half-lives. I'm talking like 200,000 years now. They were saying like, how do you design a logo that tells a human, don't dig this up, because in 200,000 years your language will be lost, and the art and the symbols that you've created might not be even like interpretable anymore. So like, how do you tell a future human, don't dig this up, and when they see that sign they know what it is? And even that in itself is a crazy idea, because like, how do you get around that one? You can't like, right, don't dig this up, because that language might not exist. Do you fall on pictures? Because things evolve, things change, everything changes. So what you're drawing now might not look like that in 200,000 years. And that's a scary idea, because then what's stopping us like coming across something that we shouldn't? And there's nothing. And then I was thinking, it just blew my mind. That's just an idea. I don't know.
It's like the pyramids, isn't it? Like the pyramids are tombs to people, and I imagine when they were building them, they wanted them to be secure and not opened. And then 5,000 years later, what's the first thing we did? We opened them up, and
yeah, totally. That's a very good point. They might have like, all the pictures on there might be saying like, please don't open these up.
Yeah. But actually, I was just thinking just now when you were talking about sort of what we're going to do with this stuff. Are we going to bury it on other planets? And I was just thinking, like, at the moment, what have we actually put out into the solar system? What have we like put off Earth? I'm not talking about like satellites around Earth, but we have like the 2 Voyager spacecraft out there doing their thing. There's, I think, a few other satellites that are sort of around other planets and stuff. And then apart from that, everything else is just space crap that we've left on the moon or on Mars.
Yeah, I was just gonna say, isn't there like wee and poo on the moon?
Yeah, like just, well, presumably there's definitely like some landers, and there's like all this like rubbish that we've just left, and golf balls and this like crap.
Yeah, it's insane. It's insane. But did either of the astronauts go to the toilet on the moon? And did they bring that back with them, or is it like in a container on the moon?
I think it's just in bags. Like, I think it's just in like dog pee bags. Like,
oh my god. See,
yeah,
it's stuff like that. We need to figure all of that out before we start doing stuff like this.
Oh yeah, we send the first people to moon, and immediately they're just like with like a giant moon space turd monster.
Yeah, insane. Yeah,
had 50 years to evolve from like basic like fecal bacteria.
Yeah,
super resistant to human killing. Like, yeah,
that's a scary idea.
Oh, that would just be that's how it all ends. That's it.
That's the real reason why we didn't go back.
Yeah.
NASA knows.
Yeah, that's no. They've got their satellites trained on it, and they just see these like mutant turds running around.
Yeah, they're monitoring them.
They've become sentient, and they're using the leftover lunar modules and leftover landing stuff to like build tools.
Yeah, they've colonized the dark side of the moon. And they're like trying to figure out a way for them to get back.
Oh dear.
But no, I think that's a pretty funny spot to kind of end it on if you want. I don't know. We've got a lot of space news.
Yeah, I think that's all I had to say on it. Yeah.
Cool.
I guess going on to the news then. The big story that relates entirely to this, and sort of bringing stuff back, is the Japanese mission Hayabusa 2 that's come back to Earth from the asteroid. I get the pronunciation wrong. Ryuga.
Yeah, Ryuga.
Yeah. So this is the mission. It's been going a long time, hasn't it? I think it reached the asteroid in about 2018.
Yeah.
I think, and collected samples, and essentially they fired this. There's a couple of sort of things of it. They took surface samples and then they fired a big bullet into it to get some subsurface samples as well. And as of today, on I don't ever remember, the 16th, they've opened up the first capsule of it. So there's these 3 capsules, and one of them contains the surface matter, and the second one that they're going to open, I think in the next few days or weeks, contains subsurface matter. And they seem to have got quite a lot of rocks and soil and stuff, and they seem to be quite happy with it.
There's a few of these happening, isn't there? This is the one that landed in Australia, right?
Mm-hmm.
Yeah. I saw the photo of it today. It looks, I mean, I was going to say it looks cool, but it's literally just some rocks, isn't it, in a capsule? But it's still awesome because they're rocks not from Earth.
Yeah.
But yeah, no, it's very, very cool. Have they said anything about it yet, or are they just literally starting to look at it now?
All I saw was that they were happy with it. One thing that they were particularly happy with was that they think they now know that the canisters that it's in not only contain the rocks in the soil, but they also contain gases that have been outgassed and have been blown off.
Oh, cool!
Sort of the process. So there's not only the rocks, but also the gases as well. So there's potential that we learn a bit about sort of any atmosphere or any sort of gaseous things that were happening. So they're quite happy with that. And yeah, they seem to have. This is obviously a massive technological feat as well. Because I remember being in school and in the Rosetta mission, was it?
Yeah.
The one that sort of attempted to land on I think that was on the comet, wasn't it? And they attempted to land on it and it sort of skipped off. And at the time, that was only less than 10 years ago. This idea of sort of landing on a comet was like the biggest thing ever. Like, this is amazing. Like, we've peaked, and then, like, now 10 years later, we've successfully collected stuff from an asteroid and brought it back to Earth.
It's very cool, isn't it? Because like you have, like, for anybody that isn't thinking how cool this is, like, this asteroid is moving, and we've sent something to it. Like, we figured out the math to line our thing up with it, land on it, take some samples, come off it, and then bring it back to Earth so that we can check it. It is insane.
Mm-hmm. Yeah,
it's very, very cool.
Like and then particularly in terms of the science, there's a lot that can be done here. One of the things that I'm looking at is if there's any signs of life, and did life come from asteroids? That's one question they're sort of asking. But yeah, I think over the next sort of weeks, more will come out about it, and we'll find out what they're doing and what they're planning to do with it. But from a tech point of view, it's just absolutely incredible. I can't even imagine. It's difficult enough being able to get there, but then like creating a rocketry to get something back from an asteroid onto Earth.
Yeah, I know, it's insane. And tell you what, it wouldn't be the Infinite Void unless we made it slightly depressing. But I'm sure there is somebody somewhere licking their lips right now going, the future is mining. We're going to be mining all of these things. We're going to make so much money.
Oh yeah, if there's any sort of traces of platinum or things like that, then Elon Musk will be up there next year.
Yeah, you wait. Elon Musk and Jeff Bezos, they'll be up there. Amazon Prime. Bringing core samples back next day.
Hmm. Yeah, definitely.
But no, it's very cool. So we've got one thing since, unfortunately, by the way, sorry everybody listening, if you missed last week's episode because there wasn't one. I wasn't very well, so apologies, but feeling a little bit better now. But got to talk about it because it was insane. It's still blowing my mind now. The SpaceX SN8 successful hop. Now, Matty, this was super cool. I must have watched this video 100 times. I must have watched all the videos 100 times. They weren't really expecting it to do as well as it did. I know a lot of the news outlets were being classic news outlets and saying that it was like a failed mission, it had all gone wrong and stuff like that. But watching that Starship, right, climb up to, was it 12 km?
Yeah.
Going up to 12,000 kilometers and then
12,000 meters.
Oh, 12,000 meters, sorry. And then seeing it literally like turn onto its side and glide was the coolest thing I have ever seen.
It was pretty stunning. It was.
And then even for it to come back down, because they thought it was going to like crash in the ocean, didn't they? They didn't think it was actually going to come back down and land, because it landed like pretty much where it was supposed to. It came in too quick, didn't it?
Yeah, it was very close. Like it did fire and it did slow down considerably, and it didn't like just fall into the earth. It did just sort of touch down a bit too hard, and it was very close.
I not going to jinx it, but I have a feeling that the SN9 could do it. I reckon we might see the SN9 land, you know. If it goes right, I could see it happening.
The weird thing is it's just so fat.
Yeah.
Like when you watch the like Falcon 9 boosters and stuff land, like it's incredible. Like it really is cool, but they look like they've been designed properly.
Yeah. No, it doesn't look real, does it? It looks like a flying silo that's aerodynamic.
Yeah. And it's got these ridiculous flaps on it.
Yeah. It's insane. It's so insane. Watching it go up and then seeing the flaps like move and then like these like streamlined bits come off it, and it was just belly flopping. Oh man, it was so cool. And watching it like level back out and do that as well, it was just incredible. I was freaking out. It was genuinely like really, really cool.
But there was the one point when, remember, like 2 engines cut out, didn't they?
Yeah.
Like halfway, and I presume that is planned. I presume that's what it's meant to do. But like one cut out, and then the second one cut out, and then just before it sort of started falling, the third one cut, and I was like, oh,
Yeah.
yeah. They managed to refire them, and the flames will grieve, which I don't think was meant to happen.
Yeah. I saw such a funny meme. It was who was it? Oh, what's his name? It was Voldemort standing on the pad doing that with like green lightning coming off his thing hitting it. I thought that was quite funny. But they were saying, weren't they? I saw somebody on Twitter. They were like trying to get SpaceX to sell bits of the metal on the website, because they were saying just cut it all up and sell it. You'd make a fortune. Everybody would buy a little piece. And I was like, yep, I would totally order a piece of that.
Like I imagine you get quite a lot of keychains out of a rocket.
Exactly. And like what are they going to do with it? Just scrap it?
I don't know. They've probably got a plan to reuse some of it, I imagine. But you know, certainly the bodywork, I can't imagine it's worth a great deal to them now.
No, exactly. But I did see that the SN9 had actually tipped, hadn't it, a little bit in the. But I think they've sorted that out. They've sorted that now with the crane, haven't they? And it's all okay.
Yeah, I from what I last saw, it sort of like fell over it fell off its pad, didn't it, or something when it was being moved. And I think it's fine. Obviously, got to do some checks and stuff. But I did see that there was possibility that SN10 was going to launch first.
Oh, okay.
Because that one is apparently also pretty much as ready as SN9 is. So if it's not confirmed, but if SN9 is delayed because they have to do checks or if anything has gone wrong, then SN10 will be almost ready. So
how quickly have they put these things up, can I just say? Because like It wasn't that long ago they were just having the little hopper bits. Do you remember? Just the small little bit that they would jump in, like 150-meter hop tests. And then I remember like 3-4 weeks ago just seeing the cones being made, and then all of a sudden it went from 1 cone to like 6 in this bay, and now they're like, aren't they all the way up to like SN15 or something that they're working on now? It's just crazy.
They seem to be like basically turning. Obviously, there's a lot going on in the background and parts are manufactured off-site and stuff, but they seem to be able to assemble these things in like a matter of weeks.
It's crazy. I wonder really, because I can imagine it's really good for like people like NASA and stuff, because this is just unheard of, isn't it? The speed in which that this is just being like knocked down. It's unfortunately because it's private, but it's cool too. But it's like you're saying, I love it when NASA are making big rockets and doing stuff, but it is awesome to see like SpaceX just keep knocking the ball out of the park.
Yeah, like the way things are progressing, I would fully expect the current NASA rocket, the SLS, to be pretty much their final rocket. Like if you get to the point where SpaceX is able to launch stuff to Mars, is able to launch stuff on deep space missions, then does NASA even have to build rockets anymore? And I really want to see the SLS launch because it's huge.
Yeah.
But like,
well, totally.
I suspect NASA's a bit torn because like they're seeing sort of someone else sort of take the forefront and a bit of the limelight. But I suspect there are people at NASA who like, this is the best thing that could ever happen. Like, if we can just get a really cheap rocket that is American, because at the moment they're relying on Soyuz rockets.
Yeah, no, totally.
Get an American rocket that has a lot of good publicity behind it and is dirt cheap, and we can just spend our budget on building space submarines and stuff.
Yeah, yeah, especially because like NASA just doesn't really get that much budget, does it? No, and it constantly, like, I swear it gets less every single year. And it's good really, because like SpaceX are like forcing the US government's hand a little bit. It's either like increase the budget to keep up with us, or focus your like expertise elsewhere and let us concentrate on the rockets and you just have the payload. Yeah. And I think that will probably be the end goal for NASA. I think they'll always have like the International Space Station and stuff. But I think I could see it going more so that way, where like NASA kind of like runs the mission more so, and then SpaceX is the contractor.
I can see SLS running for the next, however, 20, 30 years, whatever, and then by that point, commercial space would have taken up to the point where NASA just doesn't have to, because it's not just the rocket cost, it's not just the cost per rocket, it's the investment time, and there are only so many people that can work on this stuff, and half of NASA's workforce is taken up on building a rocket, then I think they'd rather have them building the actual probes and stuff and using that budget to do that. So I think it's interesting. I think it'd be interesting to see what happens. So
yeah, no, for sure.
So do you want to do your other piece on?
Yeah, sure. So
space.
A little bit more space news. So there is a company called Astra, and for anybody listening that don't know who Astra are, they are a space company that basically focus on getting things into low Earth orbit, and they want to make it a little bit more accessible. But they've recently won a contract with NASA, and yesterday, which was the 15th of December 2020, they actually made it into space, and it was really cool. It was funny because this kind of stuff is what I love, right? I don't know if you saw on Twitter, but it was funny watching them commentate on their own space launch. Was like watching a space fan commentate on watching a space launch, because they're like a kid at Christmas. They were going absolutely nuts once it passed the Carmine line and stuff, and it was so fun to watch. They were like absolutely ecstatic. And it was beautiful because their launch pad's up in Alaska. So it's absolutely stunning. And to watch this rocket, which was a bit of an unusual shape, I'm not going to lie. It looks a little bit different to like the conventional kind of rocket. It just looked amazing. And I was just blown away again. And it's cool to see another company doing it. It feels like the last year, there's like all of these new space companies coming out of the woodworks, and they're all actually having breakthroughs.
Yeah, they do seem to. This Astra one in particular, I'll be quite honest, has come out of nowhere for me. Like I hadn't even heard of them until a few weeks ago.
Yeah, it's nuts because like I remember like back in the summer, I think they were like posting photos about them testing their engine, and it was like literally in a container, and they were just like firing it and stuff. And yeah, it's insane. I love seeing all these little like private companies coming out and actually achieving getting up into space. I think it's class. The more the merrier.
Yeah, definitely. I guess sticking with that sort of thing, I had one more bit of news on Virgin Galactic. So this week they tried to launch Spaceship 2, which is their it's a suborbital flight. It's more of a space plane than like a rocket. It's launched from an actual plane itself, and then sort of goes off and does this thing. And I think, reading into it, basically, as they were about to drop the Spaceship 2 vehicle, so the actual spaceship bit of it, something went wrong. The engine didn't fire, and they had to abort it and bring it back to Earth. But yeah, from that, they say everything's okay. It was just a computer glitch, and they're planning again to launch soon. So hopefully in the next few weeks, I think they're planning sort of weeks, we actually get another launch of this, and we'll see Virgin Galactic eventually make it not quite to space, but very nearby.
Now I'm excited to see that one to get going, to be fair, because I like the idea of it, and it's, as you were saying, it's quite a nice thing, because if, as you were saying, like if things do go wrong, it can kind of just glide back down to Earth, which I think is kind of like a good peace of mind as well, especially if we're going to start venturing into like space tourism. It's a good way of doing it, I think.
Yeah, definitely. It is. Virgin Galactic is a bit of a weird one though, because it was one of like the first, way before Astra and way before even SpaceX. It was like on the horizon as like the next big thing, and they've still not done it.
Yeah.
Like, SpaceX has gone from, I don't know the exact dates, but from my perception, SpaceX has been founded and has gone from literally nothing except like investment funds to putting people into the International Space Station.
Yeah.
And Virgin Galactic's still not launched a thing.
Do you reckon that's just budget though? Because I can imagine that. Because how much is SpaceX worth now? I think it's worth like 90 billion, isn't it, or something?
I don't know.
Because I don't. Does how much? I don't actually know if Virgin Galactic has had that much successful investment and funding, has it? Because didn't it have something happen to it, like a drawback a couple of years ago?
I think it's a muddled one. I think when it was owned by Richard Branson, it was a Virgin company.
Yeah.
And then recently it got sold off, didn't it? And put in public. So yeah, I just think it's a bit of a weird one, because like I'm not trying to diminish what they're doing, but what they're doing is not like putting people into space and like launching stuff all over the solar system. They're building a plane that goes very high.
Yeah.
Yeah.
No, that's a very good point.
Yeah, I think it's a bit of a weird one. Yeah, I have one final bit, and I'm sorry to spring this on you, but I found it literally in the last hour or so.
That's fine.
Was rage. Europe's planning to build their own Starlink network.
I saw this. Somebody was super angry about it. I've already gone off on Twitter about this literally before I came on here too. I agree with you. It's ridiculous.
Like, we were talking about space debris earlier, and every single time I see these goddamn news stories, I just want to grab someone and go, "What are you doing?"
Yeah,
like,
yeah.
And like in this article's on Bloomberg, the one I'm looking at, it talks about how they want to build this thing. They've got, says Europe wants to build a $7.3 billion alternative to Starlink, and they say that the UK is already building its OneWeb system, which is our thing we've talked about before in the past, and apparently China's building one, and I could just see like there being 5 or 6 networks, all with 10,000 satellites. And it just makes me so annoyed.
Yeah, no, it makes me so annoyed because people are already annoyed about Starlink. So imagine what happens when you go and get 3, 4, or 5 more of them.
Mm-hmm.
The whole night sky is just going to be grids.
Yeah, it's just I can genuinely see this being like the tech bubble of the early noughties, like a .com bubble. We have all these companies that have launched billions of worth of equipment, and it's just entirely useless.
Yeah.
Because, like, and I'm not saying there isn't a market for it. We've said in the past about how, particularly in developing nations, this space-based internet sort of gets around all the limitations of having to like build networks, put out fiber and stuff. I'm not saying it's completely worthless, but there is only a limited market for it, and much of like the Western world, we're now seeing 5G develop, and things will continue to develop. But for me, 5G is sort of as fast as things need to get for any considerable amount of time.
Yeah.
You know, I know I've said in the past about like how, you know, we went standard definition and HD definition, and now on to 4K, and then sort of 8K's on the horizon with like video definitions and stuff. And it's a bit like, do you even need 8K?
Yeah.
Do we need it? And we're sort of to get to the point now, okay, we're just getting 5G, and it's like, do we even need to go beyond that at all?
Yeah.
You know, we definitely need more capacity. We need, you know, as we get like self-driving cars and everything goes onto the Internet of Things, like we need more capacity. But do we need faster speeds? Not really. So
Yeah.
you know, I guess I could see definitely developing nations sort of using this, but they seem to think that they could just keep, without going into economics, it's this sort of like supply and demand. Like the demand hasn't changed, and it will increase as more people get online.
Yeah.
There is a limit to the demand, which is that everyone in the world has internet.
Yeah.
You can't. It's not a market where you could just keep pushing supply.
And just hope that that people are going to keep taking it. Yeah, like there's going to get to a point where we don't need it, and it's just going to be up there too.
And that's the thing, is that it's not, you know, if a telecoms company and a normal telecoms company goes bust, well, you know, let's say Vodafone went bust tomorrow, you know, some of their sites and their masts would probably just sort of fall into disuse, and then some of them would be used by other companies. Well, if Starlink went bust tomorrow, you know, maybe OneWeb would use some of their satellites, but they're completely different architectures, and it's not like you can go out and alter them or change them in any way.
Yeah, they're just up there. Yeah.
Maybe you could bodge it and like take over their servers and integrate it somehow. Seems unlikely. Otherwise, you just have thousands of satellites just sat in space for the next decade.
Yeah, no, totally. It's absolutely ridiculous, and we don't need it. But it falls back to what we were saying with this whole like space contamination thing. Is it's like it's not egos, it's just flexing. They want the same capability.
Yeah, but what this reminds me of is like Uber and Lyft. They like with these markets, it's like the person who gets there first, like with Uber, like the first company that gets their app onto your phone is the one that you use forever.
Yeah.
Like once you have Uber, you will never download Lyft. It's just not going to happen.
Yeah.
So like they just use these very like predatory tactics of, you know, just undercut people and just make it as cheap as possible to get people to use your one. And once you got them, that's it. And I can see this going the same way, that like we get like 3 or 4 companies. We have like Starlink and OneWeb and this Chinese company and this European one. They're all up there just trying to sell you the cheapest internet until eventually some of them go bust. And
then they're just up there.
One of them remains, and we end up with this monopoly on space internet that's caused tens of thousands of satellites to be dumped. So I think it's. I was reading and I was just like, no.
Legit, legit. I feel you. When I read stuff like that, I feel like the Planet of the Apes guy when he's standing on the sea and on the beach and he sees the Empire State Building. He's like, "You monsters, you did it!" Because that's literally how I feel.
Yeah, it's just
It's not good.
It's just this again. It's this idea of I think we need more regulation and we need some international body to govern this stuff. We're letting companies sort of dictate what they want to do a bit too much, and not to get all socialist on it, but in my experience in these sort of big markets, having people just have free reign on something as fundamental and as inaccessible as space is not a great idea. But
Yeah, no, I'd agree with you.
anyway,
Yeah, I think that pretty much wraps up this week's episode. Sorry, anybody listening, if we went a little bit depressing towards the end, but it wouldn't be the Infinite Void if we didn't. We like to make you think about these things. So if you enjoyed this episode, make sure you give it a like down below. Go and give us a great rating on Apple Podcasts as well, as it helps us with the charting and the positions in the chart and all that kind of stuff. And if you have any questions or you want to recommend a topic to us, you can hit us up on the socials at Infinite Void Pod. And if you want to drop us a more lengthy email, it's theinfinitevoidpodcast@gmail.com. I'm at Jacob E. Carson, and Matty is the Matty JMP on Twitter if you want to go and follow us. And yeah, we will catch you in the Infinite Void next week. Hey everyone, we wanted to take a moment to tell you about our brand new Patreon page.
yeah, so we've devised a load of new goodies that are neatly packaged across 3 different tiers for you.
Tiers start at £3 and go all the way up to £10 a month.
Just to say, the Patreon is in no way an obligation, and we're going to continue making the podcast as it is freely available across all the platforms. But if you'd like to support us and show your support, you can now.
So yeah, head over to patreon.com/Infinite Void Pod for more information.